Welcome to Chief Science Officer's Zoom In on Science Calls, where we learn about STEM professionals and their careers to understand the impact of their job in modern life. My name is Yesu Krishna and I'm from Kenya. I'm personally excited to host today's call. So for all of us to enjoy this experience, please mute your microphones and post your questions during the presentation in the chat box. We welcome Dr. Ganesh, a professor of Arizona State University. Thanks for joining us, Dr. Ganesh. Will you please tell our participants a little bit about yourself and your work? Please share your slides and remember, participants, post your questions in the chat.
Sure, thank you, Krishna. Let me share my presentation. Okay, so everybody should be able to see the slides, and I can also see the chat. So basically what I wanted to do was to share with you a little bit about what is called biomimicry. And I actually use biomimicry in the work that I do with my students at the undergraduate level. And I present to high school students through various programs that Hope used to run when she was here. She was our director of the programs. And we also did middle school programs. But my primary job is to actually work with undergraduate students. And I teach an introduction to engineering class. And in my class, students do biomimicry. They mimic desert tortoise behaviors, trying to understand how desert tortoises that are native to the Sonoran Desert, where Arizona is, adapt to the heat. It's very, very hot here in the summer. And how do they adapt themselves to living in the desert, and what do they do? So we take that idea and we try to learn desert tortoise behaviors, and we build a robot that will mimic those behaviors. And we want students to choose the behaviors that they want to mimic. So I have had very interesting projects where students have tried to mimic biological behaviors of how the desert tortoise stores water in its pouch. So things like that, which you wouldn't imagine a robot could do, right? A robot, that you might say Lego robotics, if you've ever played with Lego robotics. So they do those kinds of things. So let me get back to my presentation. Okay, it's doing something else now. I think you can all see yourselves as well, which I need to minimize. Okay, better. So this is basically a brief introduction to myself. My students call me Dr. G, and I love reading books. I've been collecting books since my childhood. My parents were collectors of books, and I picked up the same habit. Probably between my parents and I, we probably have between 4,000 to 5,000 books in multiple languages. I also enjoy taking pictures of nature and outdoors. So here are some of the books. I actually went to my bookshelf and took pictures of a couple of sections of my bookshelf, of one shelf, so you could see what kinds of books I have. These are some classics, if you will. I also like photographing nature. This is a beautiful canyon in Arizona called Antelope Canyon. I love taking pictures of doors. I travel quite a bit around the world. And these pictures were actually taken in my hometown in India. And this is a temple. The one on the left is a door for a temple, a Hindu temple. And the one on the right, I was just walking by and I saw this sort of gate-like structure open. And through that, there were several doors. I thought, how cool is that? So I took that picture. So what is biomimicry? It's a way to learn from nature and mimic strategies that we find in nature so we can solve problems, challenges that we might encounter in our lives. And I'm going to give you some examples, okay? So you can see what that looks like. So it's also a way for us to see the world differently because we now have a purposeful aim to learn from nature and to apply that knowledge to designs that we want to make our lives better. So here is an example. Everybody's heard of the bullet train that the Japanese built. They used to sort of travel at 200 miles per hour, which is great. But what was the challenge? every time it exited a tunnel, there was a loud boom that could be heard almost 15 miles away. And that was not a very good thing. So how did they solve it? The chief engineer was a birder. He liked to watch birds. And he thought, what can I find in nature that might help me think about this problem differently? So he saw the kingfisher bird fly into water, and when it flies into water, it doesn't make any ripples because it doesn't want to alert the fish that it's trying to catch it. And then it grabs the fish and it comes out. So he thought, maybe I should look at how the kingfisher's bird's beak works, and I can use that to make the design for the train. And that's how the boom disappeared. The large sound boom for this train disappeared because he made the front of the train look like the kingfisher's beak. Here is another more recent example. Faculty in the University College London in Britain have come up with a way to regenerate water. And they used a leaf-like structure to make these tiles that have these vein-like channels, which already have algae and a sort of a hydrogel that will regenerate water in the manufacturing plants. Rather than using water once and dumping it into the drain to be recycled using a very complex system, they're now regenerating the same water and reusing it in their manufacturing plants. So why do we care about biomimicry? It's a way to learn from nature. It gets us to solutions really fast. And there's this website called asknature.org. You might want to take note of that and go explore that to see what kinds of things you can learn from nature. There's plenty of examples out there. So two key ideas in biomimicry. One is functions, the other is strategies. A function is the purpose of something. It's like, I'll give you an example which might be better. So I'll give you a second to read this on your own. Okay, now on to the example. So the purpose of the polar bear's fur is to keep the bear warm, right? It insulates the bear from the cold. Or if you think about it another way, it conserves the polar bear's heat. So what is the strategy? The bear's fur is a strategy for insulation. So we can understand how the bear's fur works and what makes it good insulation, we can perhaps use it to make better insulation for human needs. For instance, how do you better insulate buildings without having to use energy to cool our houses, which is what's going on in Arizona now. We sometimes get up to 120 degrees Fahrenheit. And that means that you're going to have to run your air conditioning all the time, which is very expensive. So if we could figure out how the polar bear's fur works, maybe there is a way for us to insulate our homes from the outside so we could keep the inside of our house cool. So that's just one example. There is this very good TED Talk. So you'll get to see this link. I'll share the presentation with you later on. I would encourage you to go watch this TED Talk. She is like the mother of biomimicry. She sort of made biomimicry popular. She's a very famous biomimicry researcher, and she has an institute called the Biomimicry Institute. Now, ASU has a branch of that institute as well. And I would encourage you to just search biomimicry in action. And if you don't want to write down this long link, which is hard to do that, you'll just find the TED Talk, okay? And that's my email address. If you ever have any questions or interested in having further conversations, I will now stop sharing my presentation so you can ask questions of me.
Thank you very much for telling us about your work. It is evident that you're truly passionate about your animals. While we were learning about what you do, participants have left questions in the chat, but let's start with 3 questions I have prepared.
Okay.
So my first question is, how do you recommend introducing biomimicry to young people?
Very good question. So the most important thing I think we need to sort of get back to doing is to be very good observers. Observe and be curious. Observe how things work, whether those things are found in nature or things that you might have at home. Like for instance, um, how does your door lock work, right? Now, I'm not suggesting you take a screwdriver and take apart your house door lock. Your parents will be really mad at you. But if you can find a scrap heap or somewhere somebody's throwing things away because they're breaking down a house and they don't need it anymore, maybe that's a perfect opportunity to grab that and take it apart to see how things work. So similarly, when you take a walk amongst nature, look for clues for how nature works. And when you watch the video presented by Janine Baines, you'll actually see how she talks about inspiring young people to observe.
That's really nice. It's really true. We can see everything and we can see and make technology out of it.
Yeah.
So my second question was, who was your mentor as a child?
Ah, I actually remember many of my elementary school teachers. So I was very lucky because I went to a small private school in a city called Mysuru in India, South India. And my class size was only 18 students. We went to school together from pre-kindergarten, which was half day, to 7th grade together in the school. For 9 years, we were classmates. And my teachers were specialists, meaning as early as 3rd grade, I had people with a biology degree or a history degree or a math degree teaching me. So I would say not just one person, almost all of my educators from my elementary school life were really my mentors because they guided us to be who we are today. I really attribute it to them because that school was very unique. We learned to explore things. It wasn't just about reading a textbook or doing worksheets. They inspired us to do science, make things and explore. And if it was perfectly okay if it failed. If we could figure out why something didn't work, that was good enough. Okay. So we had a very unique, I had a very unique experience in elementary school, which probably is why who I am today.
That is so inspiring. So my third question was, what advice would you give to your 14-year-old self?
Yes. So I again was very fortunate. My parents had lots of books. I read a lot and I also traveled a lot. My grandparents, my mother's parents traveled around the country quite a bit every year, at least once or twice a year. And I was very fortunate that they picked me because I lived in the same town as they did. And I was the only grandchild around for a long time. So I accompanied them from as early as probably when I was 8 years old until I entered high school. I traveled with them, or even until I entered college, I would say. I traveled with them at least once or twice a year. And every time I would travel, I would observe various things, how people behave, how things work, what are processes that people use to navigate the world, what kinds of things can I see in nature. You really need to be curious about how the world works. And that's what will give you the opportunity to create solutions for problems in the future. A lot of problems that we deal with are all human in nature, meaning they're related to people. That's why we care about them. We want to make people's lives better. And the only way to learn is to observe, 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 and listen, talk to people and listen to them, hear what they have to say.
Thank you very much. Now let's start with the participation questions. So the first question is from Kelly, CSO International.
Uh-huh.
Dr. Ganesh, what is one of your favorite books? You can share top three if difficult to narrow down.
I read so many different kinds of things. Books wise, I read philosophy. As I grow older, I read fiction, I read biographies. So I don't have a single favorite. I have many, many hundreds of favorites. I'm actually reading a book right now in the native language of my hometown, not my mother tongue, of my home state. It's called Kannada. The language is called Kannada, Kannada. It's a book that describes It's a fictional narrative, probably rooted in a lot of research about a sculpture that exists in a temple called the Hoysala Temple. Hoysala is the name of a royal family that ruled portions of South India for quite a while, maybe 200 years, around the 11th century. So the title of the book is called Shantala. And Shantala is a sculpture in one of those temples. This book describes very in great detail how the temple came about, what was their life like that during that time. So it's very interesting to me. I've read it before, but it was a long time ago, like probably 20 years ago. So I'm reading it again.
Oh, so our next question is from Dhruv Patel from Kenya.
Okay.
What is your ultimate goal with biomimicry?
So I'm basically, the reason why I use biomimicry in my introduction to engineering class is students go out and specialize in various things like mechanical engineering, aerospace engineering, material science, electrical, civil, you name it, right? At ASU, we have 25 engineering majors that people can pick from, 25. And that still doesn't cover everything. For instance, we don't have petroleum engineering, if you will. For that, you may have to go to a different institution. But the point I want to make to young people in my introduction to engineering class is that think of design differently. Don't try to think of design in an artificial way, meaning that you have to do everything yourself. You have to come up with these solutions yourself. Learn from nature if you can. It's a strategy. It's a design strategy. It's one way to think about how you can solve problems. If students can take that message away with biomimicry, I'll be super happy.
Yeah, we will try once. Make a project. So our next question is from CSO Austin from Pennsylvania. And he's asking, have you or your colleagues designed an effective biomimicry idea or objects?
Not myself. This is really very hard to do. It takes years of work, but I met with a group of people. So wind turbines. So Arizona is not really suited to generate electricity from wind, but there's a group in Flagstaff, which is in northern Arizona, that has a manufacturing firm. They manufacture these wind turbine blades. So I met with the director of that firm, and he just found out through the internet that I was doing something related to harnessing wind energy by way of teaching teachers and students how to learn about wind energy. And so we met over lunch one day, and there are ways to learn from nature. And there's a group of designers who looked at how the fins of a dolphin are designed with these waves on them, and they're taking that design and using that to design wind turbine blades that don't look like the ones that you are used to seeing if you've ever seen a wind turbine blade. They're different, but they're also more efficient. That's the reason why we are trying to redo the same thing. You might say, why do I want to redesign a wind turbine if it's already working? The reason why we do that is it's not as efficient as it could be. So they have found it. So not myself, but I've met with and worked with people, talked about how they're doing the innovation process. It's really complex, meaning that it's not enough to just have this idea from biology. You have to take it to design and iterate through it a million times, perhaps hundreds of times before you get a working solution.
Wow, that must be difficult.
Yes.
So our next question is from Hope, CSO International. Is there one advancement that we have taken from nature that really stands out to you, had the biggest impact?
I would say the bullet train. There's lots of ongoing examples with energy, and people are actually taking how anthills work. So if you go to the Ask Nature website, you'll see how there are anthills that are probably several meters tall. And they wonder, how does the inside of an anthill stay cool even when the outside is so hot? And they've taken the design and they've tried to build architecture. I believe there is actually a building in Harare, in the African continent, that uses the anthill idea and keeps itself cool without having to have electricity cooling that house or cooling the giant building with air conditioning all the time. So there are some very interesting examples from nature. If you go to asknature.org, you'll find tons of examples that are very, very inspiring.
Okay, so our next question is from CSO Fatima, Kenya. And she's asking, how would you say biomimicry is inspiring human innovation?
So I would say all the examples I gave you. And if you watch the Janine Bena's TED Talk, you will see her give the example of a young boy who's her neighbor, who observes things around him and comes, knocks on her door and asks her questions. And I think that's what I would like to do as an educator, is to inspire young minds to start thinking about this early, not when you come to college for a career. It doesn't matter what you study, whether you study engineering or sociology. It's a way of thinking. It's a way of problem solving. That's what I'd like people to take away with biomimicry.
Yeah, so the next question is from CSO Vritik, and he's from Kenya. In which ways have you personally used biomimicry in your personal life, and what ways can you use biomimicry to make your life easier and more eco-friendly?
No, I have not been able to do that successfully. That's very difficult to do, to use it in personal life, because it is hard to replicate nature. You know, whatever human beings make, it pales in comparison to how complex and how beautiful nature is. Even if you think about the human heart, how the human heart pumps blood throughout your body, that's a very complex thing. That's a complex part of our body that keeps us alive all the time. How does the human heart work? How do the four chambers pump blood throughout the body? What do they do? That's a very complex thing, and we cannot mimic those things very easily. That's why learning from nature is a very good idea.
Yeah, we should learn from nature. So our next question is from CSO Dhruv, Kenya. And he's asked, if biomimicry launches off, do you think that humans will use robotics to gain the extraordinary skills of certain animals? And how do you think this will affect society?
So there are actually examples of biomimicry impacting robotics. So rescue robots that mimic behaviors of snakes, robots that look like cockroaches or insects that can fly to places where humans can't go to see if there's human life, are already being used in earthquakes, landslides, and other things like that to find out if human life exists where destruction has occurred, so we can identify more quickly where they are and how to get to them. So these devices not only just go there, they can also transmit sound and video back. So robotics has already been impacted by biomimicry.
Okay, so our next question is from CSO Sarah, Kenya. When you came across a problem you can solve through biomimicry, how do you know which particular part of nature to mimic?
Yeah, so you can't do it by yourself. That's why you need to consult with experts who are biologists who study behaviors of how animals, microorganisms, nature, plants work. And you have to work with experts who have that expertise. As an engineer, I don't have expertise in biology. So what I'm advocating for is to do transdisciplinary work, interdisciplinary work. You can't be an expert in everything. You need, that's why learning is a social thing. You got to talk to your peers. You got to find out what other people are doing, how they're thinking about things. What do they know from observation? What do they know from systematic research? And you try to integrate different disciplines to solve complex problems.
Yeah, definitely teamwork. So Dhanushya asked from Kenya, why is it of great importance to explore biomimicry?
Well, for all the reasons that I just gave you, because nature is just really marvelous.
Yeah. So our next question is from CSO Vivek Raj, Kenya, and
Uh-huh.
he's asked, "What was your best moment while learning biomimicry?"
Huh. You know, it's been probably 10, well, more than 10 years. Gosh, it dates me. 14, 15 years ago that I was introduced to biomimicry. I mean, I was probably formally introduced to biomimicry 14, 15 years ago. I started reading a book by Janine Benyus, and that's how I got interested in the topic. Um, so, it's basically something that stuck with me as a way of teaching engineers to think differently. And that's why I picked it up.
Oh. So next question is from CSO Vritik, and he's from Kenya. What do you think about adding bionic features in human and or animals to boost sense?
Ooh, I don't know about that. I don't have an opinion on that. I'm not sure that's the right way to go. I don't think it's, first of all, the implications for what that means. We know what it is. That would require lots of research before you would insert some technological thing into humans or animals. Probably a little shady. It requires lots of work. So I don't know that it probably requires very what we call in vivo work, meaning inside lab work, before you can sort of take your idea to the world. It needs to be explored inside a lab, theoretically and probably simulated before you can, because there's something about protecting humans and animals. You can't harm them when you do research. So your first job is to try these ideas out in a lab in a theoretical way using technologies, simulations, what if scenarios before you can take it out to experiment on people or even experiment on animals.
Okay, so our next question is from CSO Vivek Raj, Kenya. How do you define success?
Huh. Success is really about learning from failure. We often don't learn deliberately from failure, meaning most high school students really don't experience failure. Most K-12 students in the world don't experience failure in a big way. Okay, you may fail a class here or there, but you're going to be able to somehow pass the class, right? You don't really fail big things at big things. So in engineering, we say the best way to succeed is to fail safely, fail early, and fail often. So there's this company called Dyson that makes vacuum cleaners. Dyson is a very expensive vacuum cleaner, the Dyson vacuum cleaner. Their goal was to take an 8.5 by 11 piece of paper, 8.5 inches by 11 inches piece of paper, and whatever vacuum cleaner they designed was supposed to have a footprint of only 8.5 by 11 inches. Meaning if you set it on an 8.5 by 11 inch paper, it should fit exactly within that paper. They went through so many iterations, failing at meeting the design. Of course, it had to function like a vacuum cleaner. Otherwise, there's no point in designing it. But its footprint, meaning the size of it, had to be only 8.5 by 11 sheets. So that's not easy to do, right? So they had to fail many times before they could succeed.
Okay, so our next question is from CSO Dhruv, Kenya. How does biomimicry compare to other bio approaches?
I don't know really. As I told you, I'm not an expert in other bio approaches. I'm really not an expert in biomimicry either. My advocacy for biomimicry is from the engineering perspective. So I'm not really an expert in biology because my degrees are actually in computer science and engineering and education research. So I'm trying to sort of bring these things together to influence. The point of being in a university system is not only to do my own research, but to also influence lots of young people who come there for bachelor's degrees, for master's degrees, to do research studies, to work with teachers, to work with youth like you in high schools and middle schools. So I'm not really an expert in biology who can answer that appropriately.
Okay, so our next question is from Hope, CSO International. Can you tell the group what degrees you have and how you ended up so
Yeah,
passionate about working with young students?
Right. So my bachelor's degree is also in computer science. My master's degree is in computer science. My PhD is actually an interdisciplinary PhD. In the 1990s, ASU received a grant from the Carnegie Foundation to create what was then a trend, brand new trend that hadn't picked up yet, to allow doctoral students to do interdisciplinary work. And I worked with mathematics professors, computer science professors, curriculum theorists in education, psychologists in the psychology program. It was a very unique PhD program where I learned from multiple disciplines on how to think about problems differently. And by the way, such a program did not exist. So we had to take something called education, media, and computers and use that degree. I basically broke every rule that degree plan had because the deans of various schools were on my dissertation committee helping me design what my degree program should be. We were a small group of students from Ireland, Turkey, and other parts of the world who were together in that degree program. So I was very lucky. I got to learn from experts, had access to people sitting next to each other, trying to think through what is Euclidean geometry in a spherical space? What is an arc or a straight line in a spherical space? What does that mean? That's how I became interested in learning and trying to convey that passion to young students.
So our next question is from CS Dhruv, Kenya. Who is the first person who came across biomimicry?
Ooh, I don't really know. I don't really know. I got introduced to it by Janine Benes. So I don't really know. As I said, I call her the mother of biomimicry. But what I would say is people have always learned from nature. So meaning you don't have to have an educated person is not necessarily somebody who's had a college degree. An educated person is somebody who studies the world and observes and reads and learns on their own too. Even people who can't read can be very well educated. So I would say biomimicry has existed for as long as humans have looked for solutions. It's just that somebody takes it and puts it, gives words to these practices and writes and advocates for it. And so then we give them credit for having created something. But the real credit goes to people who came before them, who learned and observed and did things.
So our next question is from Austin, and he's asking, has bioluminescent biomimicry been investigated?
I don't know. You all have to answer those questions yourselves. Hope posted something about where biomimetics came from. So basically, look for information. When you look for information, make sure that the sources are authentic. I'm sure you've been told this by your educators, but learn how to detect for what's authentic and what's not.
I think we led them to the biomimicry interest, right? So it's exciting that they will definitely have to go do some research, and we can have Dr. Ganesh back on. And the point is he's engineering and professor and really pushing his students to design, create, build, fail often, which we always talk about. So definitely explore, and we can, come back, and once school's back in session for you too, Dr. Ganesh, maybe meet some of your students and talk about what they're designing or researching.
Yeah.
Sorry, Krishna, keep going. So our next question is from Malhar, CSO Malhar from Kenya. I think you have done PhD. If yes, what particular topic was the PhD about?
Yeah, so, I did my PhD research. I started my PhD program in 1997. And if you think back to when computers became popular and the internet became popular, it was only in the early 1990s. The internet became popular or even accessible in American universities in 1991, 92. And even then, it was very isolated. It was just in a few rooms in a giant university like ASU. And all of a sudden, schools began to say, hey, we will use computers. They will replace textbooks. They will replace teachers. We will have all these labs. And they created these computer labs. So I wanted to see what unique things schools are doing. And that's how I started to look at how schools use technology. So my work was sort of looking to see, can computers be used in more meaningful ways than just a glorified textbook? Sadly, you will still find um, you will still find educational settings where computers are used as glorified grade books, if you will. It's really the power of technology has never, especially computing technology, has never fully been exploited for access to students like you. Anything else? You have more questions?
Yeah, sure. I got muted. So sorry. So
Sure.
the last question is, what inspired you to take this role and specialize in this subject?
Oh, you know, my specialization is actually engineering education, and which is about how to teach engineering in ways that make it attractive or interesting, makes it socially relevant. Why should you care about becoming an engineer? Why should you solve the world's problems using an engineering lens? That is my passion. That's who I am. What inspired me to do this? Actually, my grandmother, who only had a fifth grade education, but was very well read. She could read in multiple languages. She read profusely on her own. She was worldly wise. She used to tell me stories about this one engineer in South India who was knighted by the British because the British ruled India for a very long time. And his birthday, September 15th, is still celebrated as Engineers Day in India. And his name was Sir M. Vishweshwaraya. He created a very unique type of a dam that allowed him to conserve water and use that water to irrigate entire barren plateaus. And that the dam's design, that device that was used to dam water, was then used in other parts of Southeast Asia, like Burma and other parts of the world, what is now called Myanmar. And that's how I was inspired, because he was the chief minister of my home state when my grandmother was a young woman or a young child. And she remembered him, and she was telling me as early as 7, 8 years old about what this man had done for society. That's what inspired me to become an engineer. And I hope that I'm able to convey the same thing to other people that I interact with.
So this is the last question from CSO Vivek Raj, Kenya. And he's asking, what is your greatest lifetime achievement?
Ah, I don't know about that. That's a hard one to answer. I don't know that I've achieved great things. I think all I can say is we keep trying. I often, Hope knows this because I used to work with her very closely and almost talk with her every day. I'd say, I'm not sure what we're doing is enough or it actually has the impact I'd like it to have. I think we shouldn't rest on anything saying, okay, I've done something great and then that's it. You always need to keep saying that we need to do more and strive at it and keep striving at it. Question yourselves. Don't accept everything for what it is. Strive to do better, strive to do more.
Thank you very much for your participation today. Before we close this call, we have one final question. What advice would you give to us as young leaders for our future?
Ah, I would say be curious for life. Always be curious, because curiosity is a hallmark of how to think about the world, how to make the place better. If you're not curious about how things work, you're never really going to try to think about it differently. So be curious and learn how systems work, because you might see a problem, you're only looking at it from a surface. And if you're not curious, you won't go behind that surface and look at the bigger picture of how the system works, because not every problem has a single source. It probably has multiple things. It's like a very complex knot. And there are lots of those knots that need to be unentangled, or maybe you can't unentangle them, but you need to understand them. And for that, you really need to be curious.
Again, we thank you for joining us today. You are an inspiration to many of us, and we hope that you can participate in another call someday as we continue to zoom in on science. Everyone, please unmute yourselves for the motto. CSOs, don't just hope it happens.
Make it happen.
Thank you so much,
Thank you.
sir. It was fun to learn about biomimicry and how nature can help us do various stuffs in daily life.
Bye.